All right. So when they first start out here, you're going to notice, look at number 1. It says G, X, 5X, looks like this, plus 1. And then it's got D equal, and then in the brackets, negative 1, 0, 1. Here's what this is. The way you have been seeing the equation, they've been writing y equal 5x plus 1. Here's the equation part here. This right here, they're calling this function, here's another way they could have written it. That's a funky way of writing it. They could have written it this way. G of x equals 5x plus 1. All these three things are saying the same thing. Normally, you either see it this way, y equal 5x plus 1, or you see it this way, g of x is 5x plus 1, and here's why. You might get, and you're getting ready to get in a few weeks, more than one equation at a time, and you're trying to find the solution to like 2 equations or 3 equations all at the same time, and what you're going to find out is if you graph them, the solution's going to be where they cross, okay? So that's where we're going with this. This is why they're giving you this notation. That's going to be on another unit. So they can call the functions anything they want to. They don't want to call everything. Usually what they call things are like f of x. So if I'd have f of x is 3x plus 1, what I usually do, or I tell students to do if that confuses you, cross it out and just call it y equal 3x plus 1, because they mean the same thing. But if I'm going to get 2 or 3 equations, I can't call them all f of x. That'd get too confusing. So that sometimes what they'll do is they'll call one f of x, and they'll come along and say, well, the next one I'm just going to call it g of x. All that means is it's the same thing as y. There's a reason why we might want to write it that way, though. If you look, well, let me just give you an example, and then we'll do the actual problem number 1. If I were to put 3 in here, that 3 replaces an x, doesn't it? Wasn't it g of x? This is telling me this is my dependent value. It's like my y, but it's telling me plug in x equal 3. That's all it's telling me when I see like g of 3. Just means plug in x equal 3. So if I'm going to plug in x equal 3, I just go over here and say that's 5 times 3 plus 1, which would be 15 plus 1, right? It would be 16. So they could write g of 3 is 16, and that tells you in the equation that I labeled g, when I plug 3 in for x, I get 16 out for y. That's what that's really saying. This is my y value, and the number inside of here was my x value. It's just another way of writing it. Mathematicians get tired of writing y equal 5x plus 1 and then say plug in x equal 3. It's just way too much writing on that itty-bitty hand, isn't it? So they found another way to do it, and it was using this notation here. So inside the parentheses, they're telling you what to plug in for x. You plug it in, and you get the y that goes with it. Isn't that just evaluating an equation is all that is? Right? Y'all are looking at me. You're kind of scaring me. Man, I forgot to hit record. They're telling you the domain, the x's that you're going to plug in are these numbers here, and they want you to find the range. So one way you could list your range is to put an R. Range stands for the y's. And you could list your answers as you plug each one of these things in. So for instance, if I wanted to say g of negative 1 in this notation that they're giving me, they could put g of negative 1. Normally that's not what you see in a math book, though you could see it on your SAT just because they can pull all kinds of weird things on the SAT and assume that you'd be able to figure it out. Normally it would look like g of negative 1, though, in a math book. So that just means plug negative 1 in. So let's see. 5, I'm just going to take this 5x plus 1. If I plug negative 1 in, 5 times negative 1 is, all together now, 5 times negative 1 is negative 5 plus 1 would be negative 4, right? So we're going to list negative 4 up here. We're just going to put it in the order of whatever we plug in up here. When I write it this way, it's not necessarily true that I can say that negative 1 goes with that negative 4, but most of the time people try to write them in order. So now we're supposed to plug in 0. That's the next one they listed in the domain. So 5 times, remember I'm doing this expression right here, 5x. Sorry, I made it worse. That's 5x plus 1. So 5 times 0 plus 1 would be 5 times 0 is 0 plus 1 is 1. So we'll list that in our range over here. And then they want us to plug in what? What's the last thing they're telling me up here to plug in? 1, this number right here that I'm circling. Okay, so 5 times 1 is 5 plus 1 is 6, so I'm going to list that here. Normally, though, when you get equations, they don't give you little x's to plug in like this. They're going to do it in this unit just so they make sure you know if they give you a list, you're supposed to plug them in and then give them back the list that you got out when you plugged all those numbers they gave you into the equation. Normally, you leave it, let's see, normally, when we have an equation of a line, we're assuming that we're letting all real numbers be our domain, that we're graphing it and we're showing all the values that could show up. Here, they're just going to give you specific values to look at. Let's do.
Wait, so that's just the answer?
Yeah, thanks for pointing that out. So on 1 through 7 odd, they're giving you the list of numbers, you're plugging each one of those, and you're making your range with your list of your y values that you get. If you go to 13, we'll look at 13. It's the same thing on 13, but they're just representing the information a different way. Now they decided to represent it this way. F of x equals 5x minus 9. What did that used to look like for us? What can I cross out and change if it bugs me? Yeah, we can just cross it out and call it y if it really bugs us. Usually when you get something that looks confusing and it's got a lot of the stuff in it, you can usually figure out what to do if you just kind of go replace that with a y, and all of a sudden your brain goes, oh, I know what this is. This is easy. So you can think of it this way, and instead of giving you the list in parentheses, now they're just going to give you the list as separate numbers, which is really the same thing. They're just showing you that there's all kinds of ways you can represent information in math. What are they telling me to plug in here with f of 3? Yeah, x is 3. They're saying x is 3. So I'm going to go over here. Y is 5x minus 9, and they're telling me to plug in 3 for x. So that's why I'm just going to leave a parentheses every time I see an x so that I'm not using up so much of the iPad space. So y would be 15 minus 9, which is 6. So the answer to A is f of 3 is equal to 6. I'm just going to write it up here because you would often see it written that way. 3 is your x, 6 is your y. On the B part, f of negative 3, this is telling me what? Huh?
It said plus the x is negative.
X is negative 3. That's exactly all. That's all it's telling me. This I could write f of x equals 5x minus 9 again. It's just telling me to plug in x is negative 3. That bugs you, cross it out, put a y. Y is 5 times, okay, x is negative 3 minus 9. So that's what, negative 15 minus 9. Wouldn't that be negative 24, right? So for the B, the answer is negative 24. You could write f of negative 3 is negative 24. If you wrote it as a coordinate point, wouldn't it just be this, right? Because there's my x and there's my y. Does that make sense? Okay. So on those type problems, that's all you're doing is you're plugging it in. Look down at 29. Looking to see if I can find one that looks a little weird. They're all the same once you get down here. Now this, again, this is how you normally see it written. Either y equal 3x minus 12 or f of x equal 3x minus 12. And A says find f of 0. What's that telling me to do? Huh? Yeah, but what does that mean? What am I going to do on my paper?
Replace the x.
Yeah, plug in 0 for x, or replace x with 0. Okay, so if we do that, we could say 3 times 0 minus 12, which would be 0 minus 12, which would be negative 12. So f of 0 is negative 12. That just means when I plug in x equals 0, let me undo that line. Come on. Oh well. When I plugged in x is 0, because remember my x goes first, I got negative 12 as a y. Now if we're moving on to B, oops, let me write in black. B says solve f of x equals 0. What are they telling you now? Telling you something different. Before they were telling you x equals 0, what are they telling you is 0 now? Y, because I could cross out f of x and I could write a y and then it would make more sense, wouldn't it? So it means take that equation, 3x minus 12, and instead of writing y equal 3x minus 12, we're going to write 0 equal 3x minus 12. And if I want to solve for x now, I know my y is 12. I could solve for x. I could what? Here's the x. Let's move the 12 over here, right? I'd get 12 equal 3x. And if I divided both sides by 3, what would x be? 4. So my x is 4. Wait. I made a mistake here when I wrote this point. What did I do wrong? Yeah. This right here, what was y set equal to? Oh, I don't know why I put that over there. What was y up here? They told me y was 0, right? When I'm writing my point, didn't I start off, it said f of x equals 0, and I crossed it out and I put y equals 0? Didn't I set y equal to 0 right here? So that's what should have been over there. The y is 0. When I get y is 0, then that means my x is 4.